Hi, good day everyone. Today we are from group 4. We would like to talk about unbalanced fault. This is our group members. Our leader is Luwin Jun, second person, Nur Iriani, third person, Nur Aisyah, fourth person, Nur Afika Munirah, and our last team member is Nur Fadila Tasha. Figure 4 shows that a seat-bus power system network from phase A to ground is considered a button fault. To solve this problem, we need to perform fault analysis for each generator bus bar. Common base is given 100 MVA and 11 kV at generator 1. In generator 2, Zn is 0.03 pu based on 15 MVA. Table Q4 shows that all components in per unit based on equipment rating given by this question. First, we need to find per unit impedance for each zone. SB equal 100 MVA, for VB1 equal to 11 kV, for VB2 equal to 132 kV, for VB4 equal to 33 kV. For SB equal to 174.24 ohm, for SB3 174.24 ohm, and for ZB4 equal to 10.89 ohm. Next, we find the value of XT1, XT2, XT3, and XT4. For XT1, we got the answer J0.2 pu. For XT2, we got the answer J0.3 pu. For XT3, we got the answer J0.25 pu. And XT4, we got the answer J0.35 pu. So this is a value of power system component that already we calculate. Next, we need to find positive sequence. For positive sequence, we already draw the equivalent circuit. We need to find the fault at red arrow. To find the fault at arrow, we need to find the value of XT1 plus XT3 plus XT2. The answer, we need to parallel to the XT3 plus XTL5 seat and XT4. Then we need to plus to XT2. Then we got the answer, we need to parallel with XG1. The answer we got is 0.148 pu. Next, we find negative sequence. For negative sequence, we already draw the equivalent circuit, and we need to find the fault at red arrow. To find fault at red arrow, we need to find the answer of XT1 plus to XTL23 plus XT2, and then we need parallel with answer of XT3 plus XTL5C plus XT4. When we got the answer, we need to plus with XG2. Then we need to parallel with XG1. Then the answer is 0.11 pu. After that, we need to find zero sequence. For zero sequence, we already draw the equivalent circuit. So when we draw the equivalent circuit, we know that Z0 is J0.06 pu.
Have find the three components of zero sequence, negative sequence, and also positive sequence, we could find the line to ground fault. in line to ground fault, we need to find first the IA0, IA1 and also IA2. From these three current, we could produce the IA, IB and also IC. We got for the current A is 9.435 with an angle of negative 90 degree, while IB and IC we got 0 per unit. From all of this current, we get the fault at the generator 1 is 49.52 kiloampere. Now, what happened when the fault at generator 2? Firstly, we need to find the positive sequence. For the positive sequence is actually the sequence from A, B, C. So now the fault is at generator 2. So to find the Z1, we need to parallel between the bus 4 and the generator 2. So from that, we got 0.148 J per unit. Secondly, we need to find the negative sequence. The negative sequence looks alike a positive sequence, but it have a different order of phase. In negative sequence, the sequence of phase start from A, C, B. So now we could see the fault happened at the generator 2. So it also parallel between the bus 4 and the impedance at generator 2. So for that, we get the impedance at the negative sequence is 0.11 I per unit. Component that we need to find is zero sequence. For zero sequence, it's actually a three single-phase component when all equal in magnitude but with the same phase angle. From the circuit, it will affected by the condition of the transformer. We can see that transformer 1 and transformer 3 is a Y grounded to Y grounded transformer, while in the transformer 2 is actually a delta Y grounded, while transformer 4 is a delta Y. In zero sequence also, we have the impedance of Zn that must be included to find the Z0. So from that, we got for Z0 is 0.1 J per unit. After we have find the three components, we now could find the current at line to ground fault. Firstly, we need to find for the three component which is IA0, IA1 and also IA2. From these three variable of current, we could find IA, IB and IC. For IA, we got 8.379 with the angle of negative 90 degree per unit, while IB and IC we got 0 per unit. From this variable, we could find that I fault at generator 2 is 14.66 kiloampere. In conclusion, what we could conclude that the generator 1 for the line to ground fault, we have 49.52 kiloampere, while at generator 2, we got the fault current is 14.66 kiloampere. From both of the generator fault happen, we could say that the generator 2 have the lower fault than the generator 1. This is due to the effect of the zero sequence impedance that occur at generator 2 have the higher fault than the generator 1. So that's all from our group. Thank you.